Hello everyone, today we'll talk about the problem compare version numbers. Here we're given two strings representing version numbers, where version numbers are numbers separated by dots. For instance, 2.5.33 is a version number, or 0.1. So these dots separate integers. Those integers can be 0, can be a positive integer. They can also have some leading zeros which you have to ignore. And otherwise, the rules for comparing are simple. We only have to remember that if those two version numbers are different lengths, then we have to add zeros in our head to the right end of the shorter one. Right? So we compare first with first, second with second, and then the rest we compare, if one is missing all the other positions, as if it had zeros on that position. Right? So 1 is the same as 1.0, for instance. And we have to return whether they are equal or one is greater than the other. And that's it. So this is an implementation problem, and we just have to come up with a way to do it simply. And here is an example solution. So what we want to do is to use a built-in comparison operator. And we want to first prepare our strings such that this operator will do what we want. So, first of all, for each string, we have to, of course, split it into portions separated by dots. We can do that in Python with just the function split by specifying that it wants to split on the dot. We want to compare these numbers into integers. It's nice because this deals with all the leading zeros for free. And then we turn them into lists. So now v1, v2 are just lists of all these positions that we want to compare. And now, if we were to compare it right now, we'd only have one small problem, because those comparisons, list comparisons, are in lexicographical ordering, which means that we compare the first position, if it's equal, then the second, and so on. And if we run out of some positions, then we treat it as if it wasn't 0 exactly, but it was smaller than whatever is in the longer sequence. Right? So a prefix of a sequence is shorter than that sequence. And that's not exactly what we want. What we want is to imagine that there are zeros here. So for instance, if we have 1.0 and we have 1.0.0, then lexicographically this one is smaller. But we want to imagine that it has 0.0, and in that case it will be equal. So an easy way to do this is just to pad it with zeros from the right. So as long as the first is shorter than the second, we add zeros. The same if second is shorter than the first, we add zeros. And now we can just use the built-in comparison operator. And I've written here a fancy way of implementing this thing that we're being asked to do. So -1, 1, or 0, that typical comparison operator that you might know from languages like C++. And here's an interesting way of implementing it, by just comparing it one way, the other way, and subtracting it correctly. So I encourage you to convince yourself that this indeed calculates what we want. And that's it.